It's Dude Be Nice Week.
Hey man, be nice.
It's also Earth Week. So, let's talk hyperbolas. Okay? Alright?
Nice ones.
What?
Nice ones.
Yeah, I know. I want you to learn this because this is kind of the backbone for the whole week.
I will.
100% attention. Then the answer keys that you produce for me will be 100% accurate. Okay? So, a hyperbola is an inside-out ellipse. Okay? Normally, an ellipse is the distance between the two foci, or the distance from any point on the ellipse to the two foci is constant, okay, the sum of them. In a hyperbola, that distance we're going to subtract. Okay? So the difference between the two distances is constant. On this one there isn't, but here's a better picture. So here is the one half of the hyperbola. Here is the other half of the hyperbola. Okay? So the distance from this focus to a point on the parabola, or excuse me, on the hyperbola, subtracting this distance, that is constant. Okay? Or the absolute value of that is constant. Okay? So there's a lot more going on in hyperbolas, which is why I saved them for last. Okay? A lot of the stuff is the same. Okay? Finding the centers, finding lefts and rights and ups and downs and all that stuff, that's the same. But there's added stuff. Okay? So, let's dive into this. Unfortunately, for hyperbolas, there are two equations. Okay? There's an equation for a left and a right hyperbola. There's an equation for an up-down hyperbola. So a left-right hyperbola, x comes before the subtraction sign. An up-down parabola, x comes after the subtraction sign. Okay. A squared is always under x. B squared is always under y. Okay. So here's another diagram of what a hyperbola is. The difference of these distances is constant. It's going to be that c value that we're going to talk about. Actually, I shouldn't say that because that... actually, yeah, it would be that c value. Okay? Or fairly close to it. Okay? So, let's just dive right into it. Here are some examples of hyperbolas. Okay? Sonic boom from a shock wave. Okay? But really, you probably didn't know it, but if your lamp shade is just right, a lamp up against the wall will create the hyperbola with the above it, and then the below This planetarium in St. Louis is a hyperbola. An hourglass right here. Has a hyperbolic shape. Locating radio signals and triangulating and all that fun stuff. That's all hyperbolas. Okay? So, first thing we have to do, even before we can get to the center of a hyperbola, is we got to figure out which way it opens. Okay? It's either going to open up and down, left and right. Okay? So hyperbolas open in both directions. Parabolas only open in one direction. Hyperbolas open in two directions. Okay? So it's up and down, or left and right. Okay? Hyperbola is up, down, up or down, or left or right. Okay? So, based off of this one, looking at the two formulas that you just wrote down, which way is this hyperbola going to open? Left and right, okay. X is before the subtraction sign, so that is a left and a right. Okay? We'll need that later on. So we know that it opens left and right. Okay? Then, just like with circles, just like with ellipses, we're going to graph the center. Where is the center of this particular hyperbola? -3, -2. So we think oppositely because they're in parentheses. It looks like -3. We think +3 because we're thinking oppositely. Looks like +2. We think -2. So my center is right there. Okay. When you're doing a hyperbola, or when you're making or drawing a hyperbola, what you need to do is you need to build this box. Okay? This box is going to be extremely helpful for you to build it. Okay, to draw your hyperbola. So the dimensions of that box come from the numbers under the squared terms. So first, just like with ellipses, we're going to look at what's under the x term. Take the square root of that number, and that's going to be where the sides of the box are left and right, because we're horizontally. X is horizontal. So 9 square rooted is 3. So that means I'm going to go 3 to the left and 3 to the right. But I'm not going to put dots now. Now I'm just going to draw part of a wall. Okay? I'll fill in the rest of that wall in a minute. But for now, I'm just going to draw where that wall is on the sides. Okay? So we said our center was here at 3, -2. We said we went out 1, 2, and 3. 1, 2, and 3. Okay? So there are the sides of the walls. Now, we're going to look underneath the y squared number. And we're going to take the square root of that one again. And we're going to go up and down from the center for that one. So the square root of 16 is 4. So I'm going to go up 4. 1, 2, 3, and 4. Again, 1, 2, 3, and 4. I'm just setting the distance away. Okay? So now I can build that box. Questions on the box? The reason that we build the box is because the box's diagonals will give us the asymptotes of our hyperbola. Okay? So I need to then draw in the diagonals of the box and extend them in both directions. Okay? Because they're asymptotes, we will draw them with dashed lines. Okay? Now, the hyperbola, just like the ellipse, has two vertices. They will be the midpoints of the sides of the box that you just made on the sides that you determined in step number 1, which way it opened. So which way did we determine that this one opened? Left and right. So that means that the midpoint of the box on the left side is a vertice, and the midpoint of the box on the right side is a vertice. Okay? So we need those two midpoints of those boxes, or of this box. So the midpoints are going to be straight out from the center, left and right. So that is 0, comma, -2, and 3, 4, 5, 6, comma, -2. Oops, lost it in there. We'll just put them down here then. Okay. We now have enough information to draw in our hyperbola. And now I save the worst for last, which is actually in step number 4. Okay? We have to come up with the equations of those asymptotes. Okay? Now, here's the nice thing. Okay? The slope of the asymptotes will always be, one of them will be positive b over a, the other one will be negative b over a. And you've already found a, and you've already found b, because you had to use it to find the sides of the box.
Why wouldn't they be opposite with
If the box is square, yes, then they are. But the box isn't necessarily square. It might be, but it doesn't have to. So that will always be the slope of the lines. So in this particular case, A was 3 and B was 4. So the slope of those two lines are one's positive 4/3 and one's negative 4/3. We just happened to luck out on this one that the sides of our box were on the y-axis. Okay? If we didn't have that, then we'd have to use the center point. And how we would use that center point is we would say the center, remember, was 3, -2. So then we would go y minus -2 equals 4/3 times x minus 3. And then we'd also go y minus -2 equals -4/3 times x minus 3. So we'd go y minus h equals m times x minus k. And you have to do that twice because there's two different lines. So then we get y equals 4/3 x minus 6 and y equals -4/3 x plus 2. On a formative quiz test in regards to hyperbolas, okay? Well, actually, we'll go through them all. In regards to parabolas, which we did first, what would I ask other than graphing it? Look at your note cards, look at your notes. What would I ask? What? Vertex. Focus, directrix, one more. What? Axis of symmetry, the AOS. Okay? On a circle, what would I ask? Radius, center. On an ellipse, what would I ask? Center, foci, vertices. On a hyperbola, what am I going to ask? Center, vertices, asymptotes. That's the equation. Yeah, the equation of the asymptotes. That the midpoints are the vertices. Foci. Okay. So there's 7 things that I'm going to ask for on them.
So finding the foci for this the same as finding the foci for the ellipses?
No. Because it's different. Because in ellipses it was the sum of the distances. This is the difference of the distances. But we got to change it. Yep. We got to tweak it. This one you'll like though. Okay? So, let's find those foci. Okay? The important formula for the foci is this one. What is that one?
For the
Pythagorean theorem. You already know it. Okay?
Oh.
Okay? It's the Pythagorean theorem. Alright? A squared is still the number underneath the x term. B squared is still the number underneath the y term. C is still defined as the distance from the center to the focus. Okay? So that's still that one. Now, I'm going to pause for the cause here for a minute, and I am going to bring back our I think I got everything in there. Okay. So I got everything in there. All right. So there's our hyperbola. Okay. So C now is going to be the distance center to the focus, and the focus will be inside of the curves. So somewhere in here and in here will be the two foci. Okay? We just have to find where. Okay? So a squared was 9, b squared was 16. 9 plus 16 is 25. The square root of 25 is, so really it's just 5 because it's a distance. So since it's opening left and right, that gets added and subtracted to the x part of the center. So the foci are at 3 plus or minus 5, comma, negative 2. Or, because we can actually do that math, the foci have a distance of 5. So let me get rid of my circles here now. So the foci have a distance of 5. I gotta get purple back on. 1, 2, 3, 4, and 5. So right there is a focus. 1, 2, 3, 4, 5. Right there is a focus. Okay. Inside. So it has much the same operations, if you will, of an ellipse, of a parabola. Okay, just a couple of tweaks here and there. All right. Let's try. Should have some left on the paper that you have, right or not? No? No? All right, walk me through it. Which way does it open?
Up and down.
Y up and down?
Y squared.
Because y squared is first, or x is after the subtraction sign. Yep. Either one of those works for me. Okay. So right now, without even graphing it, I know a lot of things. I know that my vertices are going to be on the top midpoint and the bottom midpoint of my box. I know that my foci are going to be above and below my center. And I know that it's going to open up and it's going to open up. Okay? So I know all those things. Okay? Where is the center? Why 2 comma negative 3 and not negative 3 comma 2 like you were going to say first? H is attached to x, so you gotta think that oppositely, kind of like when we were doing parabolas and they were y squared parabolas. Yep. Okay. So the center of this one is at 2 comma negative 3. is my A value? Kenzie, what do you think A value is? 2? Because A is always underneath X, right? Yep. So left and right, 2. Ooh, we lucked out. Side of the box is on the y-axis. That's a good thing. It's going to help us later on. Trust me, it won't always be that nice. I know. It's not a dude be nice kind of homework. B. What's our B value? 5. 4 and 5. Oops, I went too far. One block too many. Okay. So there's our box, correct? We know, because we had said it before, we know that our vertices, ooh, that doesn't really show up very well, are right there, right? So that would be the point 2, 2, and 2, negative 8. 2, 3, 4, 5, 6, 7, 8. Yep. And now what? Asymptotes. Equations of our asymptotes. What is the slope of the asymptotes? Two-fifths or 5/2? What you got, Con? 5/2. Because it's B over A? Yeah. So that point right there is my y-intercept. That's a y-intercept of 2. That's got a negative slope on it, though. So that's going to be y equals negative 5/2 x plus 2. This one has a y-intercept of negative 8 with a positive slope. So that's going to be y equals positive 5/2 x minus 8. If you didn't see either one of those, then you'd have to do y, and think now here for a second, minus 3, or so plus 3 equals 5/2 times x minus 2, and y plus 3 equals negative 5/2 times x minus 2. And then solve those. Huh? We can draw it in Agreed? Only thing left is c. C squared is going to be what?
First,
29. So c is square root of 29. Am I going to add that to the x part of my center or to the y part of my center? Y part. So c here is the square root of 29, which means that the foci are going to be at 2, comma, negative 3 plus or minus the square root of 29. Square root of 29 is like 5.2. 1, 2, 3, or excuse me, 1, 2, 3, 4, 5.2.2. Okay. Questions on that? Follow those steps, or some semblance of them. You know, if you want to jump around a little bit, that's fine. You can't really jump around too much up to making the asymptotes. But then after that, if you want to do the asymptotes right away, coming up with the equations, come up with them right away. If you want to save it until the end, save it until the end. Okay. Foci, you can do foci right away if you want. I mean, really, after you know the direction of opening, you know what a squared is, you know what b squared is. So you can put the foci in right away if you want it too. Okay? I'm not saying you got to follow them exact, but I'm saying you got to do them all at some point. Okay? Questions? That's all I got for you today.